Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue this new series on weighty words. In this short clip, we will talk about a most important quality word used in web handling and manufacturing, and that is profile. This word will also serve us well for the two problem-solving clips that follow. I know your time is precious, so let's get started. Let us first define profile. It is the variation of something across the width of the web. That something could be internal rejects or customer returns. Those waste and delay items could be correlated or even caused by variations of web properties and or specific machine quality metrics. Sometimes the cause of profile is web handling related, such as a crooked roller or a crooked nip. More commonly, it is caused by poor web manufacturing or processing quality, such as coding uniformity or temperature non-uniformity. It is the challenge for the good troubleshooter to, when possible, connect the correct upstream root cause for the web profile to some downstream internal rejects or customer returns. That is always not an easy task, but will be made much easier by considering what we will cover here shortly. The motivation to master profile is compelling. It is usually the cause of baggy webs and often the cause of wrinkling, both of which are truly devastating and chronic web defects. However, profile variations are even more destructive to wound rolls. Nearly all tight, loose, and taper defects are made worse by profile variation, and a few, such as corrugations, are directly caused by and can only occur in the presence of certain profile variations. It is helpful to improve both communication and troubleshooting by using a compact language for profile. The primary shapes are listed here. In this and the next clip, we will show in a very applied way why these shape words are so important to the troubleshooter. On the Coarse scale, we have three elemental shapes: the taper, the smile, and the frown. Of course, there's nothing to say that we couldn't have a tipped or tapered smile or some other combination. If so, the thing that caused the taper is probably distinctly different than the thing that caused the smile. In other words, you might have two different root cause profile problems. On the fine scale, we also have three elemental shapes: the ridge, the valley, and the step. Of course, there's nothing to say that we couldn't have a ridge and a valley and a step all in the same profile or the same wound roll. Those of you who've seen thickness scanner outputs would have seen most every shape under the sun. Still, most serious problems are caused by a location of a significantly sized ridge, valley, or step. It is common, and even perhaps natural, to quantify a defect by severity. However, severity is usually the least useful of the three parameters to the troubleshooter. Let's take this simple valley as an example, but the principle holds true for many other shapes. The absolutely single most important metric for this profile is CD location. The reason being, for example, is that a valley in thickness on the backside could not be the cause for a customer complaint on the front side. The second most important metric is width. For example, a 1-inch wide thickness valley is not likely to be the cause for a 1-foot wide defect, even if they both happen to be located in the same CD location. The very least useful metric for most problems is magnitude or severity. The reason is simple. The severity or root cause or threshold of pain for a defect are continually varying, so problems come and go. However, if they ever come back in the same location, we probably have the same root cause. And when it disappears, the insult and risk could still be there, just not big enough for somebody to notice or complain about. Let us apply our new language to a very old and very common wound roll defect, the corrugation. In nearly every case, it is caused by a thickness variation across the width, i.e., thickness profile. However, not just any profile shape will make a corrugation. It must, of course, be big enough. However, even more important is that the thickness profile must be like a step that has sufficient gradient, meaning a large enough change over a narrow enough CD distance. Even worse for the corrugation is a step co-located with a valley in a very narrow region. My 5,000 Web 101 students will immediately know why. The wound roll diameter profile takes the same approximate shape as the thickness profile. This sets up the wound roll for a fight with the nip roller, which wants to slow down the layers at the large caliper diameter section on the left and simultaneously speed up the layers on the right. The net result is a shear twist in the outer layers as they're laid down upon the winding roll. Having a valley located at this step, a very common occurrence, gives the layers a stress concentration and a nucleus for the shearing to occur. Thank you so very much for joining me in this Weighty Words mini-series. Join me next week where we will talk about what may be perhaps the most commonly used and abused word in troubleshooting, and that is root cause. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.